Good afternoon everyone. I am Dr.P.Iris Punitha, Assistant Professor, Department of BCA, Bishop Bieber College. Today we will learn about flags in 8085 microprocessor. Before getting into the topic, we should know what is PSW, that is Program Status Word. The program status word, it holds the status of an instruction, and also it is the combination of accumulator and the flag register. A can be represented for accumulator and F represented flag register. So let's see the flags. Flag is also a type of flip-flops, because in flip-flop we can store one bit at a time. That is one bit instruction, we can store either 0 or 1. In flags also we can store one bit at a time. So as we all know, there are two major types of microprocessor, 8085 and 8086. In 8085 there are 5 flags. In 8086 there are 9 flags. Today we will see flags in 8085. Flag register. So flag register holds these 5 flags. In 8085, as we all know, that is the flag register holds 8 bits and the 5 bits are flags. So here D0 is carry flag, D2 is parity flag, D4 is auxiliary flag, D6 holds 0 flag, D7 holds sign flags. The flag register is a special purpose register. As we all know, registers in 8085 architecture can be categorized as general purpose register and special purpose register. So the flag register comes under special purpose register, and also these flag register consist of 8 bits and 5 of them are these flags. These flags can be called as status or conditional flags. So the first one is sign flags and it is represented as S. See here. So D7, this is the most significant bit and this is holding the sign bit. Sign bit. After any operation, if the M must be D7, which means D0, D1, D2, D3, D4, D5, D6 and D7. This is the most significant bit. For example, A is equal to 30 and B is equal to minus 40. If you are performing addition operation, means let's see A plus B. If you are doing the A plus B addition operation means, so what will be the result? Minus 10. So here the minus is the sign. Whenever we receive the result as the number is negative, if we get the result as negative number, then the sign flag is set to 1. Set means 1 and reset means 0. Let's see the another example. When A is equal to 40 and B is equal to 30, minus 30. If you are doing the same operation A plus B, the result will be 10. So here the plus, when we get the number as positive, if the number is positive, then the sign flag becomes 0. So let's see the next flag, that is 0 flag. If after any arithmetical or logic operation, if the result is 0, the 0 flag becomes set, that is 1, otherwise it becomes reset. Let's see this with an example. See here, for example, A is equal to minus 60 and B is equal to 60. When we add these two numbers, the result will be 0. Whenever the result is 0, then the 0 flag becomes 1. The 0 flags set to 1, otherwise it becomes reset, that is 0. The next one is carry flag. Carry flag is generated when performing n bit operations and the result is more than n bits. For example, if we are adding 4 bits, two 4-bit numbers, then we will get 5 bits as a result. See here, if we are adding 0 0 0 1, 1 0 1 0, we are adding two 4-bit numbers, 1 plus 0 1 1 0 1 1. We are getting 5 bits. The last number, the most significant number is considered as carry bit. During the subtraction, carry flag is also called as borrow flag. So here, when we are adding two 4-bit numbers or when we are adding two 8-bit numbers, the result, if the result is more than the n bits, then the carry flag is set to 1, otherwise the carry flag is reset to 0. So let's see the next flag, auxiliary carry flag. So this flag is used in BCD number system. So BCD number system means binary coded decimal. The carry flag is different from, see here, the carry flag is different from auxiliary carry flag. Carry flag is used in binary number system and the auxiliary carry flag is used in BCD number system, binary coded decimal number system. For example, in BCD we have to represent each number separately. For example, if we want to represent a number 19, then we have to represent 1 as 0 0 0 1 and 9 can be represented as 0 0 0 1. So we have to represent each number separately in BCD. In BCD addition, auxiliary carry is used. For example, D7, D6, D5, D4, D3, D2, D1, D0. So here I have given 8 bits here. So now 1 1 0 1 0 0 0 0. If we add two 8 bits, after any arithmetic operation, D3 generates any carry and passes it on to the D4. If we add these numbers, if we add these two numbers, it will give the carry in D3. See here, 1 plus 1, 0, here 1. This carry, D3 passes the carry to D4. This means these two numbers producing auxiliary carry here. So in this example, the auxiliary carry is set to 1. Okay, D3 generates any carry and passes it to the D4. Then the auxiliary carry is set to 1, otherwise the auxiliary carry is set to 0. Next one is parity flag. If after any arithmetic or logic operation the result has even parity and even number of 1 bit, the parity register becomes set to 1, otherwise it is set to 0, which means, let's see with an example. I have given an example that move immediate accumulator 05. So the number 5 should be placed in accumulator. It should be stored in it should be moved to the accumulator. That is 0 0 0 0 0 1 0 1. This number should be placed in the accumulator. Now we have to check. This is accumulator. Assume this is accumulator and check. We have to count the number of ones in the accumulator. If the number of ones is even, then it can be called as even parity. See in this example, there are 2 ones. So this can be even parity. Let's see the another example. Consider this is an accumulator 0 1 1 0 1 1 1 0. So now count the number of ones in this accumulator. 1 1. So there are 5 ones present in the accumulator. Then the 5 is an odd number. So the number of ones present here is 5. So the accumulator is having odd parity. In this example, we are having odd parity. If the number of, count the number of even number of ones, one accumulator has even number of 1 bits. 0 represents accumulator has odd parity. In this example, the accumulator is having 2 ones. So the problem gives you the even parity, and here the accumulator is having 5 number of ones. So this is odd parity. If the parity register becomes 1 when the even number of parity is present, otherwise it becomes 0. Okay. These all today we have seen the types of flags, the flags present in the 8085 register. Let's see 8086 flags in the next session. Thank you.